Let's call this the sketch of numbers where there are 3 lines, not exactly lines, like, what can I say, free flow, hand drawn, whatever's. Then we have 4 and 5. I'm not sure where this will go, but let's figure it out. Yeah. And there is something like a sine curve here, which, if this was the axis, it would be 0, 90, 180, 270, 360, with this as 1 and this as -1. This is sine theta, but this is theta. This line is actually theta. Kind of like that, but what's happened to this sine curve is, well, not exactly translated. It's kind of slanted. Maybe requires some research exactly what's happening, but say that this sine curve, which is sine theta, was shifted to the right, then that would be sine of theta minus x. So minus x means it goes to the right. Say, and it goes, say something like this, it becomes like this. Yeah? Say that it goes to the left, that would be theta plus x. And see that it shifted upwards from here. This it goes here like this, like this. So that would be sine theta plus x. It's going up by x on the axis. These are translations of trigonometry, and then the minus x is going downward if it goes like that. But that slant bit could be something related to sine of theta, yeah, a horizontal compression. So say sine 2 theta, that would be something like this, and then it goes. Let's try to figure this out. So sine 0 will be here, and sine of 0, 90, 180 becomes 360. Give me a second, we'll figure this out. So sine 0 is the same as sine 2 times 0. That's here. So sine 45 becomes sine 90. So the curve compresses like this, and sine 90 becomes sine 180. So it comes something like this. The curve actually compresses. It's not exactly what we have in our initial sketch, but something to do with a base as the sine curve, probably, and sort of a tilt. But that's that, yeah. So let's forget about that for now. Forget both the sine type of curves. Just so you know, cos curve starts from 1, that cos theta, because cos of 0 is equal to 1, unlike sine of 0 is equal to 0, 0. Let's continue with our sketch of numbers and see where this goes, yeah. So say that this, if this was a straight line and we have another straight line, and then there is a point of intersection, that is the solution to simultaneous equations. So say that you have two simultaneous equations, yeah. Have say 2x plus 3y is equal to 5 and 5x plus 7y is equal to 12. If you solve these two equations, you will get one value for x and one value for y, which is the point of intersection of these two lines. Straight lines because they extend to infinity. So any linear equation in two variables is a straight line in two dimensions, and the solution to these equations is the point of intersection, in this case 1, 1. Let's go further with this, yeah. So say that this equation of a line was straight line, yeah. These are two straight lines that do not intersect, so those are parallel lines. So say that equation of a line, let's not do equation, let's just say a linear equation in two variables, and these are actually two parallel lines which never intersect, because you will notice that the first equation times 2, 4x plus 8y is equal to 10, has the same x coefficients, y coefficients, but different numbers. So they actually have the same slope, but that's another way of looking at it. In essence, these are parallel lines that never intersect. They do not have a solution, because if you go through the process of elimination in simultaneous equations and subtract the first equation from the other, you will get 4x minus 4x is 0, 8y minus 8y is 0, and 10 minus 9 is 1, a sort of an absurdity from the process of elimination. So that's that, yeah. But I still feel like doing more math and not talking on the phone. So let's go on with this. Now, if this was an xy plane and this is a parabola like this, yeah. Parabolas of this sort are not learned in school because they are not functions. This bit here fails the vertical line test. If you draw a vertical line, it will touch the graph at 2 points. So it's not a function. Something like this would be a function. So it's this and it. The vertical line touches the graph only at 1 point, yeah. So that this is a function, this is not a function, but we can find the equation of this parabola with some degree of accuracy in terms of the general equation, which is x square x square is equal to a into y minus h whole square plus k, where this point is hk and the axis of symmetry is y is equal to h. Kind of a horizontal opening, right or left parabola. It's also cool, but it's not a function. Fails the vertical line test. That's that. More math to do later.